8Es, receiving students and teachers. Thank you, you may sit down. Okay, 8Es and receiving students, we are going to look at a new substrand in today's lesson. So the new substrand is on capacity or understanding capacity. All right, receiving students, I'd like you to tell your teacher or tell the class what is capacity, right? 8Es, I'm sure you already looked at capacity. Maybe last year in grade 7, you looked at capacity and you might have an idea. I think you have an idea of what is capacity. Okay, receiving students, what is capacity? Would like to give a try. All right, good. Let's have Winnie.
Capacity is the measurement similar to volume.
Okay, thank you, Winnie. All right. That's her idea of what capacity is. Receiving students? Okay. Any other ideas? Okay, we'll have Leonie, thank you.
The amount that something can hold.
Okay. Thank you, Leonie. All right, her idea is the amount of something or the amount something can hold. All right, if you look at amount of what? Receiving students? All right, let's build up around her answer, her idea. All right, we'll have Abby.
The amount of liquid in a container.
Okay, thank you, Abby. All right, did you others get that? All right, she said the amount of liquid in a container. All right, receiving students, did you get that? Okay, capacity, when you look at capacity, capacity simply means, all right, the amount of liquid that any object can hold. All right, receiving students? That is what capacity means, okay? Capacity is the amount of liquid that any object contains, okay, or that any object can hold, right? Okay, so if we look at the amount, okay, the amount of liquid, for example, if you look here, okay, you look at this container holds liquid, yes? So that means it holds capacity, okay? This container holds an amount of liquid. Now, this amount of liquid can be measured. Receiving students, it can be measured in units. Who can give us the units for capacity? Receiving students, 8Es. Okay, now we want to measure, if we want to measure capacity, what units do we use? What metric units do we use to measure capacity? Okay, we'll have Graham.
Milliliters and liters.
Okay, thank you, Graham. All right, you heard what he said, milliliters and liters. All right, those are the metric units when measuring or for measuring capacity. Now, capacity is liter, abbreviated as capital letter L. All right, liter, and milliliter, abbreviated as small letter m and capital letter L. Okay? For short, if you do not write those units in full, then you can just abbreviate them as capital letter L for liter and small letter m, big letter L for milliliter. All right, receiving students in 8Es, Right up here, I have a container, okay? A container that holds liquid, okay? Now this is a 1 liter, all right? A 1 liter bottle, okay? A 1 liter container. Now I'm going to pour the amount of water into this measuring cylinder, all right? Receiving students and 80s. Again, this bottle, all right, is 1 liter, all right? 1 liter, and I'm going to pour the amount of water in here into this measuring cylinder, all right? So we are going to try and see the relationship of this amount of water into this measuring cylinder. Now, if you look closely at this measuring cylinder, class, you look at the scale, all right? You look at the scale. What units is used here? Receiving students and 80s? Milliliters, okay? This scale, all right, is read in milliliters, okay, in hundreds, all right? 100, 200, 300, okay, up to 1,000 milliliters. So, what I'm going to do now is I'm going to pour the amount of water, all right, from this 1 liter bottle into the measuring cylinder. Okay. So let's see. Okay. 8Es and receiving students. What is the reading here? 1,000 milliliters. Okay. So the amount of water from this 1 liter poured into this measuring cylinder is 1,000 milliliters. So who can tell us the relationship here? Receiving students? Okay, Yoa. Okay, we'll have Yoa to tell us. Receiving students?
1,000 milliliters equals to 1 liter equals to 1,000 milliliters.
Okay, thank you, Yoa. All right. Like you said, 1,000 milliliters is equal to 1 liter. All right. 1,000 milliliters is equal to 1 liter. Okay. Now you know, all right, how 1,000 milliliters is equal to 1 liter. From pouring the amount of water from this 1 liter bottle into the measuring cylinder, which read 1,000 milliliters. Okay. All right, I'd just like you to look at these conversions, 80s and receiving students. All right. Okay, it says to change 1 unit of capacity to another unit, we use this rule, okay? For example, when we want to change a larger unit, liters, to a smaller unit of capacity, milliliters, we multiply by 1,000, okay? Because 1,000 milliliters is equal to 1 liter. Receiving students, I'll go through this again. If you want to change a larger unit of capacity, that's liters, to a smaller unit of capacity, milliliters, you must multiply by 1,000 in order to change that big unit to that small unit. In order to change liters to capacity, you multiply by 1,000. Okay, the other rule says that this time if you want to change a smaller unit, milliliters, to a larger unit, liters, this time you divide by 1,000. Okay, receiving students, if you want to change milliliters to liters, you divide by 1,000. Okay? If you want to change liters to milliliters, what do you do? Receiving students, if you want to change liters to milliliters, what do you do? Okay, you multiply by 1,000. If you want to change milliliters to liters, what do you do? Divide by 1,000. Okay, so receiving students and 80s, you also have this conversion table in your workbook, which you can study later on. All right, we're going to do one example together, receiving students and 80s. Okay, the activity reads, a container of cordial holds 750 milliliters. How many liters is this, receiving students? All right, we're going to do this as an example. A container of cordial holds 750 milliliters. How many liters is this? Okay, what are you trying to do here? Class, someone tell me, please. Okay, the question is saying that, is asking for you to change what? Okay, the smaller unit, milliliters, to the larger unit, right, to liters. Milliliters, change milliliters to liters. So what are you going to do? You are going to divide, okay? Divide by what? 1,000, right? And what are you going to divide by 1,000? 750 milliliters by 1,000. How do I get? right. Let's go through our answer. Okay. Okay, who's got an answer? How many liters is 750 milliliters? Receiving students? Okay, we'll have one from that group, please.
0.75 liters.
All right. Matthew, how did you get 0.75 liters?
750 divided by 1,000.
Okay. Diana, thank you. Can you help Matthew come up to the board and just do your working out or your calculation? Okay, receiving students, please give your answer, or you go up to the board and calculate your answer. Okay, thank you, Diana. All right. Did you others also do the same calculation as what she did? 750 divided by 1,000, or 750 milliliters divided by 1,000 milliliters, okay? And then one way, because you are dividing, you can move, okay, you can move your decimal point, all right? How many places? 3 places to the left. Get 0.75 liters, all right? So that's our answer for number 1. We changed milliliters to liters. We divided by 1,000. Okay. All right. Now I'd like you to do this on your own, please. Receiving students and 8Es. Question number 2 and number 3. So quickly, I'd like you to go through the question in your groups or in pairs. Question number 2, please get that one down quickly. Okay, I'll just give you 2 minutes to get that one down, please, quickly. Okay, if you need any help, please raise your hands. Okay. I think question number 2 is a simple one. We finished? Yeah, Jane. See. Cooking oil container has a capacity of 17 liters. How many milliliters is this? You are changing liters into milliliters. So if you look at the rule, what's the rule here? A larger unit, that's liter. If you want to change it to a smaller unit, milliliter, you multiply. By 1,000, okay. All right, we finished. Thank you. I think that's a simple one. Okay, a King cooking oil container has a capacity of 17 liters. How many milliliters is this? So the question says you have to change the larger unit into a smaller unit, yes? You change liters into milliliters, okay? So what are you going to do? All right, by 1,000. So can we have, let's have Vanua. Okay, Vanua, please, can you come up and write your answer? Receiving students, please go up to the board and write your answer for number 2. Yeah, 17,000 is correct. What's your zero? There's only 2 zeros. Okay, Vanua. Can you explain to the class, please?
8 times 17 times 1,000 equals 17,000 milliliters.
Okay, thank you, Vanua. All right. Okay, 17 liters to milliliters. Okay, we had to, because you are changing the bigger unit to the smaller unit, you multiply by 1,000. So 17 times 1,000 is equal to 17,000 milliliters. All right, 80s and receiving students. Okay, good. Now let's try the last one. We have 3A and B. Okay, this is a problem that you'll have to try and solve, receiving students. Okay, it reads, water is dripping into a cylindrical container at a rate of 5 milliliters every minute. Okay, Now, A, if it takes 4 hours to fill the container, find its capacity in milliliters. Okay, I'd like you to try and work that one out. A, if it takes 4 hours to fill the container, find its capacity in milliliters. Okay, discuss with your friends, 8Es, receiving students, discuss in pairs. Try and solve this problem here. Okay, read and understand the question first. Okay, again, water dripping into a cylindrical container at a rate of 5 minutes. Sorry, what did I say? 5 liters, 5 milliliters, sorry, not liters, at a rate of 5 milliliters every minute. Okay, every minute, 5 milliliters dropped into the cylindrical container. Okay? So the question is asking, if it takes 4 hours to fill the container, find its capacity in milliliters. Okay, anyone finished? Who's got an answer? Yes? No?
The question said the content, the water dripping into the cylindrical container at the rate of 5 minutes every minute. So you need to change 4 hours into minutes. Let's multiply by 60 minutes, and then you multiply by the milliliter. So you're right.
Okay? Please, if you're not sure, if you need any help, please put your hands up, or you can ask your friend. But if you've got an answer, yes. Okay, yep, yes. Okay, good. Any more answers? It takes 4 hours. 4 hours to fill a container. Okay. All right, 80s receiving students, I think we'll correct A. And I'd like you to complete B for your homework, okay? You complete B for your homework, and you can also do the other additional activities. Receiving students, please take note of that. We'll only correct A now, and B, you can do that for your homework, and your teacher can correct that later on. All right. Can we have someone to please give us the answer for A? Receiving students. Quickly, let's have someone to give us the answer for A. Find the capacity in milliliters. Okay, and I'd like you to cross-check with your working out or your answers. Okay, let's have the mic, please. Okay, class.
The water drip into a cylindrical container at a rate of 5 milliliters every minute. Okay, 5 milliliters in every minute means 60 seconds equals 1 minute. So 60 seconds, I got 60 here. 60 times 5 is 300. Okay, 300 milliliters in 1 minute. 300 milliliters times 4, because it takes 4 hours to fill the container. So 4 times 300 is equals to 1,200 milliliters in 4 hours.
Okay, I'm sure you others, you have another way of calculating, yes? You have another way of calculating your answer? Okay, Eddie's calculation, all right, is also correct, okay? It's 60, not 60, what did you say, Eddie? 60, you said 60 seconds in an hour, 60 minutes in an hour. Okay, sorry, explain again.
5 milliliters drop in 1 minute. Okay, I got 60, because 60 seconds equals 1 minute. Okay, the drop-in rate is 5 milliliters, so I multiplied 5 times 60, 300 milliliters in 1 minute. 300 liters in 1 minute. So I multiply 300 times 4 is 1,200.
Okay, thank you, Eddie. All right. Okay, like I said, you others also have your own way of calculating. Your answer should be 1,200 milliliters. Okay? 1,200 milliliters in 4 hours. Okay, we'll stop here, 80s and receiving students. In our next lesson, we're going to look at receiving teachers. We're going to look at converting capacity to volume. Receiving teachers, our key phrase for today is understanding capacity. Thank you, ATs and receiving students and teachers for participating today.